as a global endeavor, one that relies on bringing together the best minds and deep collaborations to address the world's big challenges. In essence, both CERN and CAUS are global organizations that embrace the culture and aspirations of the worldwide scientific community. Born in Germany, Rolf heeded the advice of one of his high school teachers that a career in anything other than physics would be a mistake. He studied nuclear physics at the University of Stuttgart and completed his PhD at the University of Heidelberg. After 14 years at CERN and 10 years as professor at the University of Hamburg, Rolf returned to CERN as its Director General in 2009. His first task as Director General was to bring the 27-kilometer underground collider, which I'm sure you hear more of it, which was out of commission, back to life. Today we are privileged that Rolf is here to open this year's Winter Enrichment Program. Rolf will give us an insider's view of the collider, a true marvel of technology, and the research at CERN, which holds the tantalizing promise that in 2012, our understanding of the universe we live in will change forever. Ladies and gentlemen, please join me in welcoming Professor Rolf Peter Hoyer to the podium.
So, good morning, everybody. It's my pleasure to be here, and I thank very much for this invitation. And I must say, I arrived last night. Nonetheless, I had a short stroll around the Discovery Square, etc. And I can only say, CAUS is changing. It's really changing tremendously since the first time I was here, I think 2.5 years ago, and it's changing really in a very good direction. So, congratulations to everybody involved as a first thing. I mean, this is a fantastic achievement. It looks very, very nice. So now I need my glasses to see how this works. Okay. So, research at CERN, from the highest energies to the smallest particles. You see, we know how to work with high technology, but not with... Okay. So, that's the mission of CERN. The mission of CERN is fourfold. Of course, our raison d'etre is research. But you cannot do research without innovation, technologies. You cannot do it without education, and you cannot do it alone. You need people. So CERN is also about uniting people. And the first thing, of course, research, we want to push forward the frontiers of knowledge. For example, we want to understand the secrets of the Big Bang. We want to understand the development of the early universe. So what was matter like within the first moments of the universe? You cannot do these things. When you work at the frontier of research, you have to work at the same time at the frontier of technologies. So you have to develop new technologies, for example, for accelerators, for detectors, but also in information technology. You wonder why I have here the web. Well, the young people, 20 years old, they don't know a world without the web. Some of them think, okay, the web was born with the universe. It's not true. Not quite true. The web was born 1989 at CERN. Yeah? When our experiments became so international, so global, that we needed a platform, a software platform, so that everybody who had the right to access the data had access to the data. immediately on the spot. And, well, you only have to look, HTTP, / column, that can only come from a physicist. Today, we go beyond the web, we go to the grid, that means computing all over the world, computing connected all over the world. And of course, also there's medical applications. I have one transparency on that. Now, you cannot do that without training scientists and engineers of tomorrow. And all the countries, they are missing engineers, they are missing scientists. And CERN is a fantastic training ground, not only for physicists, but also for engineers. And, of course, unite people from different countries and cultures. And this is a photograph of one of the recent summer schools at CERN, where we have summer students. I think you find a lot of similarities between CERN and Karlsruhe at that point. Okay, CERN was founded in 1954, originally by 12 European states. And what was not only science, it was really science for peace. Yeah? Imagining all these countries who had war beforehand sitting around the table talking to each other. Today we have 20 member states. Here you have the member states, they are all from Europe. We have already since 2.5 years Romania as candidate for accession. Since October, Israel is in the pre-stage to membership. We have applications from Cyprus, Serbia, Slovenia and Turkey. Actually on Wednesday I signed the agreement with the President of Serbia for the accession to CERN. And we have made a big step forward now. CERN, the E in CERN stands for Europe, Centre Européen. Now, we have now changed the E in CERN from Europe to everywhere. That means all countries, independent of their geographical location, can become members of CERN. So we are really becoming a global laboratory very soon. We have roughly 2,300 staff members. We have nearly 1,000 other paid personnel. Most of them are young postdocs. We have a lot of fellowships for young postdocs. We have more than 10,000 scientific users who are, not, of course not everybody is all the time there, but they come frequently to the campus. And our budget is this year roughly 1 billion Swiss francs. So as I said, science is getting more and more global, and you see here, this is the distribution of all the CERN scientific users, not by their passport, but the passport of their institute, by the nation of the institute. And you see 65% come from the member states, roughly 30% from the other associated states, and nearly 10% from all over the world. Altogether, we have nearly 100 nationalities registered at CERN. One of the important aspects are the education activities. We have CERN teacher schools all over the year, international and national programs. National programs means the teachers get the lectures in their mother tongue. That means they can use these materials directly in their classes at home. And once I talk to these teachers when they have done the courses, that's also hands-on experiments and lectures from scientists. They are remotivated, they have sparkling eyes, yeah? And our hope, of course, is that these teachers produce more physics students. And this is a photo of last year's summer students, nearly 300 summer students last year at CERN for 2 months. So whoever survives this might become a young researcher, and we have school for high energy physics, computing and accelerator every year in one of our member states, and every second year also in Latin America in addition. So we have a very, very rich training program and education program, and that shows you where the teachers are coming from. This is a program which runs now since more than 10 years. It started very slowly, but we are now at 1,000 teachers per year, and if you take 50 weeks per year, that means at least 20 teachers per week are doing the course. So it's really a fantastic way of working. And you see we also had already one teacher from Saudi Arabia at some stage at CERN. Okay, one more slide on technology and innovation. I mean, example is medical applications where you combine physics, information technology, biology and medicine to fight cancer. Hadron therapy is one of the key issues here. if you treat the tumor